I do that? All right. Hello. Welcome, everybody. Welcome. What are we doing? What are we doing? We are going to be talking about the abacus. That's what it is. That's what I do. Okay. So we're going to do 500. No, 5,000. That's what we're going to do. 5,000. What 5,000? This is the 5,000. So it's 5,021. So on the abacus, we're going to do 5,000. That's what 5 looks like. 5 is the top bead. The top bead is always 5. And so when we have 2, notice that the top bead is not touching this reckoning bar. Anytime the beads are touching the reckoning bar, that's what's being counted. Hello, everybody. Hello. So what we're doing is we're learning how to read the abacus. And I'm doing 21. 21 looks like that. Notice again that anytime the beads are touching the reckoning bar, that's what's being counted. Because it's being counted, this is 5,021. And for those of you that are interested, I do have this abacus available in my shop. So, hello everybody, hello. What we're doing is we're understanding how to read the abacus. We did 5,000. This is 5,000. 5,000 is always going to be the top bead. And then we did 21. 2 and then 1. Notice that it's in different columns. We have our ones and our tens, our hundreds and our thousands. So, I have, the next number is 4,660. So we have 4,660. Well, what does that look like? Again, remember that anytime the beads are touching the horizontal bar, this reckoning bar, that's what's being counted. So we have 4,000, we have 600, 5, 6. The top bead is a value of 5 and the value of 1 is the bottom bead. And then we do 6 again. So we have 4,660 with a 0. Notice with the 0 has nothing to do, is not touching the reckoning bar, so we don't need to count it and we don't need to color it in. However, but make sure you know that it's a placeholder. Because we have a placeholder, we need to make sure that it's 4,660. 4,000, 1, 2, 3, 4, 60. The top bead is always 5 and the top bead is always 5. So we have 5, 6. So notice when we do 5 and 6, we have what? We have it, we can decompose. Decomposing is 5 plus 1 is 6. 5 plus 1 is 6. And our next number is 3,639. Hello, everybody. Hello. We are learning how to read the abacus. I wonder if I could do that. All right, so 3,000 is this. 1, 2, 3. This is 6. How do I know? The top beat is 5. The bottom beat is 1. Together, they are 6. Hello, TikTok Tea. Welcome. It's a little... I am here later. I was doing some grocery shopping. So we have 3, 1, 2, 3. That's 30. And then this is 9. 5, 6, 7, 8, 9. Welcome, welcome, welcome. Thank you, everybody. Oh, guess what? I have a new sound bit. Welcome, everybody. Those of you that are just joining, thank you so much for joining. Please keep your mind open for something different.
Now, open your mind to me, please. Open your mind.
So we have 3,000. It's 1, 2, 3. We have 600, 5, 6, and again 3, 1, 2, 3, and then 9, 5, 6, 7, 8, 9. And then we have 2,348. We have 2,000 on our abacus. We have 2,000. We have 348. So we have 2, 1, 2, 3. 1, 2, 3. 4. 1, 2, 3, 4, and then 8. 5, 6, 7, 8. We have one top beat and 3 bottom beats. Together, you can decompose 5 plus 3 is 8. And so I'm going to color it in on my abacus. I'm going to have 2, 3, 4, and 8. That's it. So when we're looking, we have our 2,348. Hello, everybody. Hello. We are reading the abacus. For those of you that are interested in learning how to read the abacus, it is very, very easy. My next number is 8,113. 8,000 is 5, 6, 7, 8. Because these beads are touching my reckoning bar, this is being counted. None of these are counted right now. But if I do this, that's counted. This is 1. I do it again. This is 1. And then 3. 1, 2, 3. Oh, like this one. You know when we have to add to subtract?
If you're going hard enough left, you'll find yourself turning right.
Oh, right. That makes perfect sense. Turn right to go left.
Because we have to add, but to add, we have to subtract. So if you know how to go left to go right, you'll know how to add to subtract. Ah, so we have 8,113. That's what we have. How is that wrong? So we have 8,005, 6, 7, 8. We have 1 and then 3. 1, 2, 3. How is that wrong? I don't know what you're talking about. I'm sorry, I don't even know how to put Gia. Gia, how is that wrong? So we have 9,333. That's what we're doing right now. Let me see if I can make it a little bit closer. There we go. So we have 9,333. 9. 5, 6, 7, 8, 9, right? The top beat is a value of 5. The bottom beat is a value of 1. There's 4 here. 1, 2, 3, 4. We have 5 plus 4 is equal to 9. And then we have 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So we're going to color it in on the abacus. We're going to do 9, 5, 6, 7, 8, 9. We'll do 3, 1, 2, 3, 1, 2, 3, and then 1, 2, and 3. There you go. So our next number is 1812. We have 18, 1, 8, 1, 2. How did that work? Well, anytime the beads are touching the reckoning bar, right? Anytime the beads are touching the beam, we have counted. So this is counted. This is 1. This is 8. 5, 6, 7, 8. This is 1. And then this is 2. 1, 2. So we have 1,812. And now we're going to color it in. We have 1,000. We have 800. 5, 6, 7, 8. We have 12. 1 and then 2. That's what we're doing. So now we have 1912. Well, if it's 1912, we just need to add the 1 like that. So we have 1, 9, 1, 2. We have 1, 9. How did I get 9? 5, 6, 7, 8, 9. 5, 6, 7, 8, 9. We have 1 and we have 2. 1, 2. So we have 1,912. There you go. So what is our next number? We have 2,790. 2,000, whoa, hold on. 2,790. So 2,000 is a 1 and a 2. We have 7, 5, 6, 7. We have 9, 5, 6, 7, 8, 9, and then 0. So that is 2, 7, 9. How did I get it? Hello, Billy. Thank you. Right? It's easy, simple to use, easy to understand. We have 2, 1, 2. We have 7, 5, 6, 7, and then 9. 5, 6, 7, 8, 9. Don't forget that there is a placeholder of the 0. So we have to make sure that this is our ones place. When the ones has a 0. This like this one, just like this one. We have 5, 0, 2, 5. 5,000, the top beat is always 5, right? The top beat is always 5. This is 0. None of the beads are touching the horizontal bar. This is 2, and then this is 5. So when I color it in, we have 5, 0, 2, and then 5. Welcome, Angel. Angie. Welcome, Angie. I forgot how to use this thing. Oh, you knew how to use this thing? That's really cool. So we have 6,837. So we have 6,000, 5, 6, 8, 5, 6, 7, 8. And Angie, did you use, what kind of abacus did you use? 1, 2, 3. And then we have 7, 5, 6, 7. Yeah, my school teacher told me that. Oh, that's cool. What kind of abacus was it? How many beads did it have? So we have 6,837. Was it a 10 bead, or was it a 2 and 5, or was it a 1 and 4? This is a 1 and 4. So we're going to do 6, 5, 6. We do 8, 5, 6, 7, 8, 3, 1, 2, 3, and then 7. 5, 6, 7. Oh, that's very different than what I have. What I have is a Japanese abacus, and this Japanese abacus, we have a one bead on top and 4 beads on the bottom, and we actually use formulas and concepts. Whereas the 10 bead that you had, it actually was just doing a 1-to-1, and it's still very good, but it's a different method. So our final answer is 9,125. When we're looking, we're going to do 9. We have 9, 1, 2, 5. 9, 5, the top bead, all these columns that are touching the horizontal bar is being counted. So we have this one, we have this one, this one, this one, and that one. So all of these are counted. These are not counted. Notice this is 0, and these are zeros. So when we do this is 9. How do I know? The top bead is a value of 5. So we have 5, 6, 7, 8, 9. And then we have 1. Notice we just need the 1 bead at the bottom. The top bead is not touching, so this is not counted. So this is why it's 1. Again, we have 2 beads, 1, 2. The top bead is not touching. Oh, good, G. This top bead is not touching. Hey, you know what? It's going to be pretty soon. It's going to be your turn to figure out what these numbers are. So I'm just showing you what they are. So the top bead is not touching the horizontal bar. So that means it's not counted. That means we have 2, 1, 2. But this one, the horizontal bar, the 5 is touching. So this is 5. So on the abacus, we're going to do 5, 6, 7, 8, 9, 1, 2, 1, 2, and then 5. Are we ready? Are we ready for your turn? It is your turn. I'm going to give you some abacus that you need to figure out, and then you have to let me know what it is. So, no cheating. All right. How are we doing? So, thank you so much for liking the live. Thank you so much for liking the live. What is our number? So, I have my first number. We're going to start here, and we're doing a abacus maze. For those of you that are interested, I do sell the abacus in my TikTok shop. So we have this number. What number do you think this is? Please let me know. We have our thousands, our hundreds, our tens, and our ones. Hello, TikTok team. Yeah. Oh, good. Right? 8,000. 8,670. Well done. Rodneo. Well done. Thank you, TikTok T. How about G? G, did you get it? So we have 8,670. It goes this way. So we take it to here, and then we have our next number. What number do we think this is? I need a better... Hold on. Okay, there we go. Is that better? Okay, so we have our thousands, our hundreds, our tens, and our ones. What number do we think that is? We have our thousands, our hundreds, our tens, and our ones. What number do we think that is? Thank you for the follow. 6,546. Well done. Thank you, Rod. Thank you, Give. Thank you, David. Thank you. Ja or Ya? Not sure. Yes, so that's correct. So now we have this number. So what number do you think that is? We have... That's not right. There we go. So we have our thousands, our hundreds, our tens, and our ones. What number do you think that is? So this is my abacus maze, and what we're doing is we're learning how to read the abacus. After we learn how to read the abacus, we will go into understanding how to add and subtract. Hello everybody. Thank you so much for joining. Please keep your mind open for something different.
Now, open your mind to me, please. Open your mind.
Well done. Thank you, TikTok T and Lucy and hey, Casey and David. Well done. So we have 6,239, and we go over here to this number. What number do you think this is? We have our thousands. So anytime the beads are touching the reckoning bar, it's being counted. So this is being counted. Then we have our next number, that's being counted. This is counted, and then this is counted. What number do you think this is? Hello, thank you. 8,558. Well done. Ooh, Casey, almost. 0, 0. That's what the 0 would look like if none of the top bead is touching. That's what 0 is. But the 5 is touching. So we have 8,000, 5, 6, 7, 8. We have another 5, 5, and then 8. 8,558. 5, 6, 7, 8. So you got the 8, but you forgot the 5s. So that's what that looks like. 8,558. Well done. Thank you. Yeah. Yeah? I'm not sure. I'm a little confused. It just depends. We have our, so again, anytime the beads are touching this reckoning bar, it's being counted. So we have this number is being counted. This number is counted. We have this number and then that number. What number do you think this is? This is our thousands. This is my hundreds, tens, and ones. What number do you think that is? Thank you, Lucy. Yes. So we have 3. We have 3, 1, 2, 3, 9. Aha, wrong one. There you go. 5, 6, 7, 8, 9. We have 7, 5, 6, 7, and then 1. Thank you. Thank you, Lucy. Yes, thank you for the correction. Yes, 1,200 sauce. Well done. 3, 9. It is not 3. 3 looks like this. That's what 3 looks like. We had the 7. So we had 5, 6, 7. And then we had the 1. So you were almost there. Almost. Well done, Carter. Carter, it is not 6, 7. 6 and then 7. That's what 6, 7 looks like. Come on. 3,000. All right. So we have this one over here. What number do we have? We have our thousands, we have our hundreds, we have our tens, and we have our ones. We have our thousands, our tens, nope, hundreds, tens, and our ones. When we look, we have the top bead touching here, and we have the top bead touching here. But we do not have the top bead touching here. So what number do you think that is? Okay, cool. Okay, good. Is this thing good for adding, division, subtraction, multiplication? Yes, it is. Thank you, Lucy. Yes, 7, 5, 6, 7, 0, 5, 6, 7, 5, 6, 7, and then 2. Well done. Well done. Nice. Thank you. So we have 7,072. That's what that looks like. Good. So then we have our next number. We have our thousands, our hundreds, tens, and ones. How are we looking? What's going on? Oh, excuse me. Yes, thank you, Coco. It is 4,000. So we have 4,000. We have 954. Well done, David. Well done, Coco. Can I buy this game for my uncle? Yes. Oops. Hey, Shannon. Okay, yes. So it's 4,954. Well done. Well done. And we're going to continue on. So we have our next number over here. So we have thousands. Notice none of the beads are touching. So this is all 0. But then if I have this one touching the reckoning bar, it's counted. This is a reckoning bar. These beads are touching the reckoning bar. So this is also counted. So what number? Thank you, David. Thank you, Lucy. Well done. So Kurt, I'm not sure. There's no 4. When 4 looks like this. 1, 2, 3, 4. But they're not touching the horizontal bar. Great. Thank you. Hey, Giselle. Giselle, don't forget that this is the ones place. So The ones place, it needs the it needs the placeholder. Let's see. Sauce? No. That's okay. That we're all learning. This is all very new to everybody. So we have 7, 5, 6, 7, 5, 6, 7, and then 0. So when you're looking, the 1 looks like that. This is 7, 10. 7, 10, 1, and then 0. It is not 8. 880 looks like that. 880 looks like that. 5 looks like this. 5, 10. 5, the top beat is the top beat is a value of 5 and then 10. So the blue beat, exactly, Sauce, yes. So the blue beat is always 5. 5, 5, 5, 5, 5, 5, 5. When we're looking, we have that. Here's our place values. We have 10,000, so 5, 5, 5, comma, 5, 5.55. That's what that means. So we have 55,555 point. The decimal sits between our ones and our tenths right here. It doesn't sit on a place value. It does not sit on a column. So then we have our tenths and our hundredths. So that's a very good question. Well done. Why does this make my column? Plus, I'm dyslexic. You know why? Because it's easy to see. So when we're looking at it, we do 1, 1, 1, 1, 1, 1, 1, 1. See that? And when you're looking, it makes sense. So it's very visual. These are representations of numbers. So you have 2, 2, 2, 2, 2, 2, 2, 3, 3, 3, 3, 3, 3, 3, 4, 4, 4, 4, 4, 4, 4. Okay? And then we did 5, 5, 5, 5, 5, 5, 5, 5. Notice when I do 6, the top bead and the bottom bead together make 6. So we have 5 plus 1 is 6. And then 6, 6, 6, 6, 6, 6, 6. 7, look, 5 plus 2 is 7. We know, we can see it. 5 plus 2 is 7. So this is 6. And I need to make it a 7, I just need to bring it up like this. That's 7, 7, 7, 7, 7, 7. Right? And then 8, we have 5 plus 3. 5 plus 3 is 8. So we can do, these are 7s. This is 6. This is 7, 5, 6, 7. This is 6, 5, 6. And then this is 5. Do you see that? But then what's 4? 4 looks like that. 1, 2, 3, 4. Notice I remove the top bead. It is not touching the horizontal bar. Because it's not touching the reckoning bar, we don't count the 5. This is why this is 4, which is different than this. This is 7. So we can do, what are we doing? So we have 3, 1, 2, 3. Again, if I bring this down, then we have 8. If I take this away, none of these 5 is not touching, so then it's not counted. If it's not counted, then this is 3. If I bring it down, then this is 8. If I bring it down, this is 9. Great. But I'm calm with this. Oh, good. I'm so happy, Sauce, that you're very calm with this. Thank you, everybody, for joining. Please keep your mind open for something different.
Now, open your mind to me, please. Open your mind.
I would be able to follow you, show I'm the person who I'm. Hello, CS. Yes. So, oh, cost. Hi, Broad Street. We're all. We're also. We're no, Broad Street. We're unfamiliar, not dumb, unfamiliar. Is this what the, yes, you're right. Yes, thank you, tie-dye trekker. This is an abacus, and all we're doing is we're learning how to read the abacus. Is this a more common version of the abacus? This is actually, you know what, Joker? This is an updated version. It's an updated version because Japanese made it more modern and there's more concepts. And so with the concepts, I'm going to teach you the concepts, but to understand that what we're going to do is we're going to be adding, subtracting. But the first thing we're going to do is you're going to have to let me know what number you guys think this is. What number do you think this is? I was like digressing a little bit. So, me after one live. SpongeBob! Hey, welcome back, SpongeBob! How do people use this for math? We do adding, subtracting, multiplication, and division. Vinters! I haven't been stuck for. I thought it was before wizards. Thanks for teaching me. What's an abacus? An abacus is a counting tool. Oh, thank you, Holt. Thank you. I'm sorry. I need to focus. 6708. Well done. Well done, Holt. Well done. Yes, thank you so much. It's 6708. Vinters, I was waiting for more questions. It is not 675 because 5 would be here. 5 would have to come down, but 5 is not touching. And then 9 would be that, but it's not 9. So it's actually 6708. Well done, well done. Thank you guys. Thank you everyone for joining. Hey Char, welcome back. Welcome back. Midnight. It is midnight. I was lifing and I forgot the time and I'm like, I need to go. So here I am. I don't know where. Oh, there it is. So the answer is 6708. That's what we're doing. So now we're over here. We have our thousands. Notice that the beads that are touching the reckoning bar is counted. This is thousands. This will also be counted. We have our hundreds. This one is counted. This is our tens. And we have our final one, which are ones. Happy to see you. Thank you, Char. Thank you, Char. Oh, sorry. How do you count on the abacus? This is what we're doing, CS. Once you can see, you can't unsee it. This is wild. I'm sorry. I've been practicing using numbers on my receipt. Oh, that's cool, Vinters. That's really cool. Always happy to see you. Oh, yes, thank you. So we have 1, 8, 5, 6, 7, 8. We have 3, 1, 2, 3, and then 4. 1, 2, 3, 4. When we're looking, how do I know the place values? The place values are located here. When I'm looking, every column is a place value. We have our ones, our tens, hundreds, thousands, and our 10,000s. Welcome, everybody. Thank you. Does it only do positive numbers? Yeah. If you did negative, you just have to keep it in your head, just like in regular math. You have to keep the negative in your head. So you could do negative numbers, but you just have to keep it in your head. Oh, 5,000, 1,000, sorry, 1,800. Thank you, everybody. 1,834. There you go. There you go. And then it takes me to here. And then we're over here. So we have our thousands. That's being counted. We have another hundreds. That's being counted. We have our tens. That's counted. And then we have our ones. That's counted. Are you telling me you're actually... Yes, you can actually do math with this. Yes, you can. You can do adding, subtracting, multiplication, and division. Yes, you can actually do... You can do all the basic arithmetic. Hello, everybody. My name is Lynette. What we're doing is we're reading the Abacus. If you're looking for Abacus books, I have it available in my TikTok shop or over here. We are going to, after we learn how to read the Abacus, we're going to learn how to move the Abacus. After that, we're going to do adding, subtraction, multiplication, and division. Wow, so many people. Oh, yeah. I know, right? Crazy. So, yes, Jokester, you can do all of it. 150 people only. Come on. It didn't do good because there's no absolute value, right? Absolute value? Wouldn't that be absolute value? I'm not sure. I've just seen cannot be unseen. So we have our thousands, our hundreds, our tens, and our ones. I don't know I don't know what absolute value. I don't know what absolute zero means. So we have our 3, 3, 8, 3. Well done, everybody. Thank you, Kim. Burley. Thank you, Maria. Thank you. Thank you. So we have 2, 2, 2, 2. Okay, yeah, there it is. 3, 3, 3, 3, 8, 3. Oh my goodness, we're almost done. We are almost done with the maze. For those of you that are interested, it is available in my other store. I will be bringing it into the shop. I just haven't gotten it yet. I haven't gotten my stock yet. So we have our thousands, our hundreds, our tens, and our ones. So don't forget, if the beads are not touching the reckoning bar, they're not counted. But don't forget, the 0 is a placeholder. So we have, I would love to learn not being a negative nanny. Yeah, no, I understand. But I don't know what an absolute 0 is, so that's above my pay grade. I apologize. So yes, 5908. Well done, well done. And that's it. That's it. No, there's more. But wait, there's more. Because what we did is we understand how to read the abacus. Now what we're going to do is we're going to understand how to move the beads. Right? So, for those of you that are interested, thank you so much for joining. Thank you so much for joining. What signifies? Oh, hello, dragon. This one right here. There's an indicator. If you see that, this dot right here tells me that this is the ones place. That's the label. That label is. I'm gonna use that at work. It's above my pay grade. Yeah. Sneaky dragon, do you see that? So with their with the label is my ones. So I have my ones, tens, hundreds, thousands, 10,000s. And notice over here it'll be my decimal. My decimal is my tens and my hundreds. However, if you want to choose this one over here, oh no, I need to move it. There we go. Oh yeah, if I choose this one over here to be my ones place. So notice I have groupings. So there's a dot here and the dot here. It groups it. So it tells me that this is my ones and this is my thousands. However, if I choose this one to be my ones,
Pokemon, I choose you.
Then I can move everything over and then it's about perspective. So then I have my ones, my tens, but I have no more room for thousands or for hundreds. Because I have no more room for hundreds, I still have, but I do have a lot of decimals. So when I'm looking, I can actually have 0.00, I'm sorry, 0.0001. So what would that look like? It would look like this. 0.00001. That's what that would look like. Oh, sorry. That's what that would look like. So you're doing less. You are doing less. You are doing less. And when you understand concepts, you don't need to worry about all the other different strategies that mainstream abacus does, mainstream math does. You're absolutely right. Okay, so that is 0. Oh, interesting. Thank you. So, if you get used to doing this, it's easier to do math with money. It is very easy. So going back to here, that's what the decimal is. So, but I choose this one over here.
Okay, Charizard, I choose you.
That means I could do this, right? So my ones, tens, hundred thousands, 10,000s. So then it would look like this. If I had my number, right? If I did the 5, right? 5555555. It would look like 55,555.55. Or the other one is 9, right? 999. 99999. Looks exactly the same. To be honest. You cannot use the abacus, you cannot use algebra, geometry, trigonometry, finite math, infinite math, calculus, pre-calc, what else? Derivatives. You can't do any of that. What you can do here is just adding, subtracting, multiplication, division. You can find your interest rate, right? If you have a problem with interest rate, then that's a little bit about algebra, but it's the concepts. The concept, as long as you know how to do basic arithmetic, you can do it on the abacus. Other than that, there's nothing else out after that, if that makes sense. But no, I mean, people keep asking, like, can you do so many other things? It's like, no, this is just a counting tool. It just counts for you. It just tells you what the number is. That's all it is. That's all it is. Okay. Oh, I can use can I use? I don't know what partial differential equations are, and I don't know what a proof of for a real analysis is. To be honest, I was thinking I could use it through my engineering career. I don't know if you could. As long as it's basic arithmetic, then you could do it. But other than that, I couldn't see it. Walk into a class looking all fancy. Okay, so for those of you that are interested, the way the abacus is built is it's got these edges. Because it's got these edges, Bring it to class anyways. You know what? You might look a little bit more fancy if you had your own that's like single colored as opposed to rainbow. They might think it's a toy, but it's not. This one is a 13 column abacus and it works exactly the same, but it's just bigger, like, because size matters, right? So because it's bigger, you can actually do more numbers. So if I have my ones, my thousands, my millions, billions, and then trillions. So when we're looking, these labels are helping us understand where the commas are. But then you can also choose any one of these to be your ones place. So then you have all of this to be your decimals, or you have all of this to be your whole number. So yeah, yay for million. So yes, we could do 1 million. So we do ones, thousands, and then millions. Million would look like that. So it'd be 1,000,000,000. That's what it would be. Middle of a final exam, you hear the beats click like a... Yeah, that's funny. Or they can do it mentally in their head. I love your videos all about the abacus. I have the one with the reset button. Oh yeah, the one with the reset button is kind of fun. And that one happens to be a 23 column abacus. And this one specifically is made out of bamboo. And I have a reset. There's my reset. And this is 23 columns, and it works exactly the same. It's got the little notches, right? The little indicators. And it goes to, I think, quadrillion. I don't remember. But what's like 23? And then, yeah, if you notice, it's a little bit quieter as well. So, you teach and inspire so much. Thank you. Oh, thank you, Jay. I appreciate that. Everyone's anxiety. Everyone gives anxiety. That's the one I got, but I bought your color one. Oh yeah. How would I fit that one in my backpack? You know, it can fit in the backpack. It's as long as a keyboard. It's shorter than a keyboard. So if you can fit your keyboard, I don't know if you can see that. If you can fit your keyboard. See, there's my keyboard. Funny. You guys are so funny. Fold it. Oh yeah, like a phone. You could fold it like a phone. Okay. So, okay, when we're doing the abacus, when we're using the abacus, don't be aggressive. Don't be aggressive, because if you're aggressive, then the beads will move and then your answer will be wrong. And then you're screwed. So make sure when you hold the abacus, hold it with your left hand and be gentle. You want to be gentle with the abacus and you want to be intentional. Don't flick, because if you flick, then you have the wrong answer.
And flick. Oh, you flick too hard, damn it!
So what we're going to do is we're going to understand how to move the beads, and that's what it was, right? We understand we want to move the beads with intention. What we're going to do is we're going to talk about what? Okay, so here we are. This is a book that I created. It is the Preschool Abacus Math. This was meant for children of 3, 4, and 5. At 6 would be pushing it unless they're really falling behind. I wouldn't use this book for a 6-year-old. I think for the 6-year-old, I would use the mazes. So for anybody that is interested, I do have the mazes in a book format. We did, there is a 2-digit maze and a 3-digit maze, and that's what we did when I was asking you where the numbers are. And I gave you the opportunity to color it in, and you have the mask maze. The mask maze is meant to cover the path of the The reason why is because the answers are right there, and it's easy for our eyes to see what the numbers are, to see what the answers are. So I give you the opportunity to download the mask maze, so then you can print it on your own paper that you like. This is actually made out of file folder. So backpack. I want everyone to know I'm serious about math. So this one is the mask maze. This is the maze, and then I give you 2 different ways of doing math. 2 different ways to do the maze. This one is you find the number, and I give you the path, and then what you need to do is you need to color in the abacus of the corresponding number. So it's always the number behind or whatever. And that's what that is. So there's 2 sets of mazes. This one is 3 digits. We talk about the hundreds, the tens, and the ones. This one is only 2 digits. So this is probably good for 6-year-old, 7-year-old, 8-year-old, or the 8-year-old, I guess, would also do the hundreds. Here they can talk about the tens and the ones, and again, it's the same thing. The maze, there's a maze that you have to color in, And then there's the reverse maze. That is where you find the answer and then you have to color it in. So, I love this live, but I have to meet. Okay, yeah. Thank you, Vinters, for dropping by. Oh, Vinters, thank you so much for dropping by. Did you want to see my... Yeah. Yeah. I will see you in my next live. Have a good night. Hello, M. Okay, so this is the preschool abacus. Preschool abacus is it's just for kids that are 3, 4, and 5, and we talk about the numbers of 0 to 4 because we talk about 0 to 4, and then I give you activities to strengthen the idea of what 0 to 4 is, and then after that we do 0 to 5, and I'm just going to do a little flip through of the book. So we have 0 to 9, 5 to 9. Understand the numbers, right? Again, all it is just recognizing the numbers and understanding what the beads are. And then we talk about like activities. After the activities, thank you for the follow, Joker. After the activities, then we start counting forward. And then after we counted forward, the idea is that if I give you the number, then you need to know what the next number is, and then you count backwards. And this is just an extra page, and then this is so now what we're doing is we're understanding the relationship of the beads, the relationship of numbers. That's what it is. It's the relationship of numbers. So then after that, if I give you the before and after, just tell me what the middle number is. This is why it's geared for ages 3, 4, and 5. And then we have the middle number. After the middle number, what comes before and what comes after. And then we talk about bigger than and less than. Started preschool, definitely what he would be getting. Oh, hey, that'd be good. That'd be good. Oh, I do have it available here. If you're looking for a bundle, I do have that. So this is comparing which one's bigger and which one's smaller, and then it does more comparison. And then after that, we're going to go into adding and subtracting. So this is what we're doing. So in Abacus World, thank you. Oh, thank you, Maria. No, thank you. I appreciate that. So here, and it comes the bundle that I pinned. It comes with the actual abacus as well. Okay, so mainstream math in Abacus World. Well, thank you everybody for joining. Please keep your mind open for something different.
Now, open your mind to me, please. Open your mind.
I know it might be difficult. But keep your mind open and then just kind of bear with me for a little bit. Trust the process. So in Abacus World, what we do is we focus on the second number. The second number is what dictates whether or not we're going to use a formula or not. So here on my abacus, I'm going to add 7. 5, 6, 7. I'm going to add 7 on the abacus. Then I have to add the 1. The question is, can I add the 1? Yes, we can. Hey, thank you. Thank you, Czar, for checking in. For those of you that are interested, go ahead and check in by my head where there's an orange heart me. That's to check in. So then we want to add the 1. My final answer is 8. I added the 1. My final answer is 8. 5, 6, 7, 8. Notice that none of the beads over here is touching. These are not counted. Whatever is touching is my counted bead. So touching the reckoning bar, this is the counted bead. This is 5, 6, 7, 8. So we could do it again with the 2. Notice with the 2, it's the same thing. It's the second number. What are we trying to do? We're trying to add our second number. So if I have 6 on the abacus, I want to add 2. Is there enough to add the 2? Yes, we can. Yes, we can. We can add 2. 1, 2. So my final answer is 8. We're not focusing on the result. Mainstream math in school focuses on the result, but in Abacus we don't focus on the result. What we focus on is the second number. So we're going to continue on. I want to do 5 plus 3. Right? We have 5 plus 3. That's 8. We could do it mainstream. They do dots. You could do dots or you could do tally marks. I like to do it on the abacus. However, I can now scale it though, right? Because we know our 1s, we know our 10s. So I can actually say 50, 50 plus 30 is equal to 80. 80. You could do dots, but that's a whole lot of dots and that's a whole lot of counting. And I don't have time for that. So you could do that. You could even do it with the hundreds. I do 500 plus 300. Notice my 800. 800. So Abacus is scalable because why? It keeps your number. It keeps track of your numbers. That's all it does. And because it's representation, there's representation right here. Every column is represented. So it doesn't matter how big or how small your number is. So now you know how to add. You go to the horizontal bar. Subtracting, you go away from the horizontal bar. That's it. You know how to add. You will know how to subtract. So if I add the 4 and I take away the 2. If I add the 5 and I take away the 6. That's what we're doing. So we're understanding if you add to the horizontal bar, you go to the horizontal bar to add, and then you subtract, you take it away from the horizontal bar. Anybody have any questions? How are we doing? So when we add the 2, we have 3 on the abacus. I want to take away 2. Can I take away the 2?
Come on, do it. Do it.
Yeah, I can take away the 2. So my final answer is 1. Hello, Nice Tree. Welcome back. Welcome back. So again, we do the 4 and then take away the 3. And then we do 5. Adding of the 5. We add the 5 to the top and then we take away the 5. So that's what we're doing. We're adding the 5, take away the 5. That's it. So we add the 9, take away 6. Right? We add 5, we take away 6. See that? So what we're doing is we're moving the beads. That's what we're doing. We have the 6, adding of the 6. So if I have 3 on the abacus, I want to add 6. It just means 5, 6, bring it together. That's it. Take it apart, bring it together. So you know how to add, you know how to subtract. That's it. And what we're doing is understanding the number pattern. You'll see. So if I have 1 and then I want to add the 8, I can take away the 8 or I add the 8. That's it. Okay, how are we doing? Welcome, everybody. Welcome. Thank you for joining. Thank you for joining. My name is Lynette. Thank you, Nice Tree, for the rose. Thank you so much for the rose. How are we doing? Thank you, everybody, for joining. Please keep your mind open for something different.
Now, open your mind to me, please. Open your mind.
So for those of you that are interested, my name is Lynette and I am an Abacus teacher. I've been teaching Abacus for about 20 years. If you're looking for books, I do have my books available in my TikTok shop or over here. What we just did is we learned how to read the Abacus. We already learned how to move the beads. Now what we're going to do is we're going to do some addition and subtraction. So this is where it comes a little bit different than mainstream because in mainstream regular school, what they do is they count up. There's a lot of counting and there's a lot of counting up. But in Abacus, we don't count up. What we do is we do a concept. The concept is understanding this. 4 plus 1 is equal to 5. That's what we're trying to do. Why? Because we're trying to utilize this 5 right here. When would we need it? We would need it when we need to add the 4. Notice what? Notice I'm not going to memorize 4 plus 4. What I'm going to do is I'm going to have 4 on my abacus. That's what I'm going to do. I'm going to have 4 on my abacus. But then, what I'm going to do, I need to add another 4. So before I do that, I go do 1, 2, 3, 4. Right? 1, 2, 3, 4. And then what I'm going to do is I'm going to add this 4. But there's not enough beads. I don't have enough beads. What do? We're going to add the 5. But that's too much. I need to take away 1. So I take away 1. My final answer is 8. 5, 6, 7, 8. I can show you again on my abacus. I can add the 5 and then take away the 1. And my final answer is 8. 5, 6, 7, 8.
If you're going hard enough left, you'll find yourself turning right.
Oh, right. That makes perfect sense. Turn right to go left.
That makes perfect sense. You want to add, you need to subtract to add. So what did? We added the 5, but that's too much. We need to subtract the 1. So we could do it again. We have the 3 on the abacus, right? I want to add 4, but to add the 4, I need to use this 5 because I have no more room. I have to use this top bead. This top bead is what I'm trying to use. So this 5 is the top bead, but that's too much. I need to take away the 1. So I add the 5, so my final answer is 7. 5, 6, 7. I have the 5, and I take away the 1. And so my final answer is 7. 5, 6, 7. Does that make sense? So what we're doing is we are subtracting when we need to add. We're not counting up. That's not what we're doing. What we're doing is we have some restrictions on the abacus. Because we have some restrictions on the abacus, we have to work with what we have. Thank you. It is 7. So we do it again. So we have 2 on the abacus, 2 on the abacus, and I want to add 4. To add the 4, what am I going to do? I need to add the 5, but that's too much, and I take away the 1. What I just did is I balanced the equation. So my final answer is 6. 5, 6. So I could do it again on the abacus. Add the 5, take away the 1. And my final answer is 6. Hello, everybody. Hello. Thank you for joining. Thank you for joining. My name is Lynette. And if you can keep your mind open for something different. Where is it?
Now, open your mind to me, please. Open your mind.
Oh, yeah. Thank you, Maria. Yeah, not a problem. Oh, yeah. So the cat's in the tree. So the cat's in the tree. Thank you, Nice Tree. Thank you, Nice Tree, for reminding me that. So what I did here was I have 5 cats in the tree. If I have 3 on the abacus, I have 3 on the abacus, and I want to add 5, right? No, I'm sorry. I want to add the 4. To add the 4, I need to go to the cats in the tree. So I grab 5 cats and I go to the I try to grab 5 cats. I try to go to the tree that has 5 cats. That's what this is. I go to the tree that has 5 cats. I grab 4 cats. 1 cat runs away. If 1 cat runs away, then my final answer is 7. Because if you look, 4, you're going to make 4 cats. These are the 4 cats, but then 1 cat runs away. So that means that's why you have to take away the 1 from the 3, because 1 cat runs away. We can do it again with this 4. So we have 4 on the abacus. I go to the cats in the tree because I have no more room. I have to go to the cats in the tree. And then what? I grab 4 cats, 1, 2, 3, 4, and then 1 cat runs away. 1 cat runs away. Does that make sense, Nice Tree? So what we're doing is we're understanding how to utilize this 5. This 5 is the tricky part. Once you understand that, then everything else is easy to understand. Thank you, Telly, the dev. So we could do it again. Thank you. I was trying to explain it to my boyfriend. Oh, here's another way. Here's another way. Maybe this will help. I have 4. 1, 2, 3, 4. Then what happens is I have 4 in the abacus. Because I have 4 in the abacus, 1, 2, 3, 4. I have another 4. Because I have this 4, I don't have any more beats. But guess what? I have a package. This package is 5. 1, 2, 3, 4, 5. I don't want to break it apart because it's too much energy. But I need to only use the 4 that's in here. 1, 2, 3, 4. Guess what? I'm going to trade this in with this one over here. So that means I'm going to take this one away. So my final answer is 8. Did that make sense, Nice Tree? So now we have 8. 5, 6, 7. 5, 6, 7, 8. So what we did is we did an exchange. I gave you a package of 5, but we had to take away the 1. So that's what we did. The package of 5, right? That's the package. I'm only using 4 cubes. But then this one has to be taken away, but I don't want to break this package. So I have to take it away from here. And I take it away from there. So my final answer is 8. I hope that made sense. So for those of you that are trying to understand, what we just did is we went left to go right.
If you're going hard enough left, you'll find yourself turning right.
Oh, right. That makes perfect sense. Turn right to go left.
Yeah. It makes perfect sense. But what it is we're trying to balance the equation, right? We're trying to utilize a concept which is 4. If you notice, 4 is another way to equal to plus the 5, take away the 1. Because we have 5, we want to take away the 1. That gives us 4. right? If we want to have 3, we have to take away 2. If I want to have 2, I have to take away 3. So just like in our hands, we're using our hands as the constant, but the numbers that we're trying to add, we have to start taking away. If I want to use the 3 from my hand, I want to use a 3, I have to take away the 2. Yeah. Oh, good. Oh, good. Yeah, I'm trying to find different ways to explain it because I know the concept is a little different. The concept is different than mainstream math. So thank you everybody for joining. Thank you everybody for joining. What we're going to do is let's do a little review. How to count on the abacus. We do 1, 2, 3, 4, and then 5. This is the value of 5. Anytime the beads are touching the reckoning bar, this is what's counted. So this is 5, 6, 7, 8, 9, and then now we have 10. 1 and 0. So then we have 11, 12, 13, 14, and then 15. That's what 15 looks like. 16, 17, 18, 19, and then 20. So I think, Nice Tree, what I would do is I'd say the package. I think the package is easier because you could see that there's the individual cubes, and then you know you're going to be utilizing these 4. So we could do it again with the 3. Because if you notice, the 3, we have 2. We have our hand, we want to use the 3 fingers, but then 2 needs to get taken away. But we don't want to chop our hand off. That's brilliant. We don't want to chop our fingers off. So guess what? We're going to use the loose beads. Brilliant, right? Okay, so what does that mean? Let's do it. Let's do it. I like that, right? 1, 2, 3. Let's do 3. And then we want to add 5, but we don't have enough beads to add the 5. So 1, 2, 3. We do 3. We don't have, oh, maybe I'll go back to here. We do 3. 1, 2, 3. And then we got to add the 5, but that's too much. I got to take away the 2. So this is the same thing. We could do it again on our abacus. Add the 5, take away the 2. See, the concept is trying to understand how to plus the 3. Plus the 3 is plus the 5 minus the 2. Now, let's do it again. If I have 3 on the abacus, right? I can use my hand. I could use my hand. I only need these 3 fingers, right? I only need these 3 fingers, but guess what? These 2 have to go away, but I don't want to chop my fingers off. So I have to take it away from here. So now I have 5. 1, 2, 3, 4, 5, and then 6. There you go. Yeah, that's so cool. Yeah, I think that's what it is. And so then we could do it again with the 4. We have 4 on the abacus, and we want to add the 3. We want to add the 3. There's not enough. What do? Well, we have that 5 cents. We have the 5, but that's too much. We have to take away the 2. Same thing with our fingers, right? If I have 4. 1, 2, 3, 4, and then I need to add 3, but guess what? I have fingers. Because I have fingers, I'm going to use these 3, but I need to take away these 2, but I don't want to chop them off. So what do? I have to take it away from here. So if I take it away from here, then I have 5, 6, 7. Whew, that's a little dark, but I think that will work. It's a little dark. Not gonna lie.
If you're going hard enough left, you'll find yourself turning right.
Oh, right. That makes perfect sense. Turn right to go left.
So for those of you that are interested, what I just did is I added, but I subtracted. But we had to add to subtract. That's why I have that sound bit. Anyways, so for those of you that just joined, thank you so much. Grow a garden trading. Are you being rude? I'm not following any of the comments. Okay, so for those of you that are interested, here is my abacus. This is a counting tool. So what we're going to do is we're going to learn how to count. We will count 1. Anytime the beads are touching this reckoning bar, that's what's being counted. So we have 1, 2, 3, 4, and then 5. The top bead is 5. After 5, we have 6, 7, 8, 9. After 9, we have 10. Notice that's 10. How did I get 10? 10 is ones, tens, hundreds, thousands, 10,000s. So when we look, this is 1, this is 10, this is 100, 1,000, and then 10,000. Thank you, Ray. So what we're doing, what we just did here is we added and we added. Because we added, we wanted to make sure we don't memorize 3 plus 3. What we do is we understand how to make a 3. So, oh, that's a very good question. This dot right here, it's an indicator. It's a label. This label tells me the ones place. So that's why I have my place value, and I can do that. And then notice there's another dot here. This is grouped by thousands, right? These are group separators. So you know if this is my hundreds, this is my thousands. However, if I choose this one to be my ones, then you can move it everything over and do that. So then you have our ones, the tens, and then the hundreds. After that, we have our decimal. The decimal sits between our ones and our tenths. So we have our tenths, hundreds, thousands, 10,000s, and then 100,000s. What is the first two sets? Oh, that's the decimal. Yes. So this is the decimal. But so if I choose this one, over here, like a Pokemon.
Okay, Charizard, I choose you!
Then I move everything over and it would look like that. So we have my ones, the tens, hundred thousands, 10,000s, and then there here would be my decimals, my tenths and my hundredths. Yeah, no, thank you, Patrick, for asking. That's a very good question. I appreciate that. Okay, so for those of you here, thank you for joining. Please keep your mind open for something different.
Now, open your mind to me, please. Open your mind.
Okay, and then what we just did is we counted on the abacus. So when we're looking at it, we're just counting 1, 2, 3, 4. So if this is 4, this is 4. This is 44. This is 444. 4,444. 44,444. 0.44. And that's it. So when we're looking, we have our place values. That's how the place values work. And then we just counted. So you'll notice that if I wanted to add 5 plus 3, it gives me 9. We can decompose 5 and 3 is equal to 9. We could do 5 plus 4 is equal to 90. This is 98. We have 6. 5 plus 1 is 6. 5 plus 2 is 7. That's it. So we're going to continue on to how to make a 2. Making a 2, same thing. If I have 3 on the abacus, 1, 2, 3, I want to add 2, but I don't have enough, right? I have 3. I don't have enough. I need to utilize the 5. Because I utilize the 5, I can put that down. But then what happens is I got to take away 3 because 5 is too much. So I could do it again on the abacus. Add the 5, take away the 3. My final answer is 5. We could do it again with the 4. So 4 on the abacus, 1, 2, 3, 4. 4 on the abacus, right? And then I want to add the 2. Now, when I add the 2, I don't have enough, right? There's not enough room to add the 2. I don't want to do 2 here because that's 24. That's not what I'm trying to do. What I want to do is I want to add 2 to this column. So to add the 2 to this column, I have to utilize this 5. This 5 would be too much. So just like my nickel, if I have the 5, that's too much. I need to take away the 3. How do I know? Because remember, 2 plus 3 is equal to 5. So that means that if I bring the 5, I have to take away the 3. So I have to take away the 3, and my final answer is 6. 5, 6. So we could do it again on the abacus. Add the 5, take away the 3. And so my final answer is 6.
This is the way.
This is the way. This is the way.
How are we doing? So what we're doing is we're understanding how to read the abacus. Is this my book? Yes, it is. Thank you so much. So this one is my book. This is the +5, and this is all talking about. I'm sitting here for my calculus exam. Oh, hey, Pix. Good. Good luck. Good luck with your calculus exam. So in the book, it starts off with understanding how to make a 5, and I put in number lines because I wanted to relate to mainstream math. And then we talk about the cats in the tree and understand how 5 is related to each other. So you have to find the missing numbers, and then from here you have examples on how to add the 5, or add the 4, you add the 3, add the 2, and add the 1. Now the reason why I did this is because in Abacus world, we focus on the second number. The second number dictates whether or not we're going to use a formula or not. So in this question here, you'll see if I have 3 on the Abacus, my question is do I have enough? Oh, I can't see that. Do I have enough? Can I do it?
Come on, do it. Do it.
Yes, I can do it. I can just do that. But now when I go here, I don't have enough. I don't have enough room for adding the 1. So that's why I would have to add the 5, take away the 4. And that's just one of those questions. You just need to memorize that concept because this is the fact family. Fact families are one of those things that is being taught in mainstream, and it's very critical when we do abacus as well. When we add, subtract, knowing your fact family will be very crucial. Thank you. Hello, Gonzal. Do you have these lessons for for teaching the traditional soroban? This is the traditional soroban, unless you're asking for a different one. What does your abacus look like, MF? What does your abacus look like? This is surprisingly interesting. Oh, thank you, Griggies. So, MF, what kind of abacus are you using? Because this is a traditional one. I meant traditional lessons. Oh, yes and no. So abacus is a structured. Abacus shows that it's very structured. So the questions are very specific. You start from understanding how to add from 0 to 9, but there's some questions that you're not going to be able to answer until you get to here. Does that make sense? So when we're looking, there's a bunch of questions that you start off with. Here is the addition table, and if you notice the addition table, the way I have it color coded is that this is all this is simple, meaning that there's just the same. That there's enough beads for it. This right here is what we're learning is how to make a 5. You'll notice that this is what happens in traditional, that you have to memorize 4 plus 4. But in Abacus world, we don't memorize what 4 plus 4 is. What we do understand is how to make the 5, how to add the 4, and then we do it again. We don't memorize what 3 plus 3 is. Does that make sense? So the concept is different, but I do provide all the questions available in mainstream math to Abacus math. And that's what I'm trying to do, is I'm trying to relate Abacus to mainstream math. But mainstream math, it's disorganized with all the numbers that's being there. Okay, thank you, Nice Tree. Have a good night. Okay. Yeah, sorry. And so after understanding the single digits, then we go into double digits and then triple digits. And then after that, we go into multiplication and division. But then you'll notice that it's a lot easier. And I have 3 boys and they all gone through Abacus, and I actually never helped them with their math homework until later, like when they start going to like 5th grade, 6th grade, because then the concept gets different, right? Like doing what do they do? They like talking about shapes and what the fractions are. Those are different. You can kind of do it in Abacus, but fractions is just another way of dividing it, but it's another way of the concept. Do you have a source for traditional lessons? I'm very interested in teaching this for my class. I do not have a source for traditional lessons. I am trying to. What grade are you looking for? Hey, Jeremiah, how's it going? What grade are you planning to teach? I guess that would be the question, because I'm trying to relate it to the specific grades, but I'm only looking at arithmetic, so I'm not looking at how to tell time or what the shapes are. That's your question, Gonzo? I'm going to have to mute you. If you're going to be rude, I will mute you or I'll block you. MF, did that make sense? So I guess what the question would be is what grade or what grade level are you? what MF Bay 5 and up. So 5 and up, if they're in preschool or if they don't know their numbers, then I do have a preschool one. Hopefully. Oh, thank you, Jeremiah. Yes, thank you. I hope you have a beautiful night as well. It's not that bad. It's not that bad today. Today the trolls are not that bad. Ages 5 and up. So I would wonder, I guess, because I'm thinking like, if you're if you're going to be homeschooling, or I mean, I guess it depends if you're talking about like traditional math, or are you planning to teach this in mainstream school? I guess that's the question, right? So yeah, I would wonder like, because the way I try to break it up is the concepts. Once they understand the concepts, then it doesn't matter. Not mainstream. Yeah. So it depends on the concepts. It always depends on the concept. So like if the 5-year-old doesn't know their numbers, then you can start them with this, whereas the preschool abacus, and we talk about the numbers, and we talk about like how to count forwards, how to count backwards. We have like what's greater than and what's less than. And then we go into adding and subtracting. So it's kind of traditional. Like you kind of look at it, but we don't focus on the result. What we do focus on is the second number. The second number is what dictates whether or not we're going to be using a formula. That after this would be this one. Hey, Jeffers, welcome. So after the preschool one, I would take them to do the adding of the 5, and that's what I was talking about, how to make a 5. And so, because I learned how to make, because I was teaching how to make a 5, then the concept of subtracting, adding and subtracting would make sense. Yeah. So then after this, you would have to, after this, I would teach how to take away the 5. After you take away the 5, because why? Because once you know how to add, you will know how to subtract. So here's the question. If we added, right, we knew how to add. We added plus the 4 is equal to plus the 5 minus the 1. You'll notice that they go down, right? And then when we want to subtract, they go up. So you see that there's a number pattern. You see that there's a number pattern that goes with it. You go down and you go up. If I want to add the 4 or take away the 4, you know how to add, you know how to subtract. And it goes again, right? We could do it again with 16. So 16 on the abacus, I want to take away the 4. Take away the 4 is minus the 5 plus the 1. And then we could do it again with the 3. The 3 is the same, right? When we add 7, or no, we have 4 on the abacus. I want to add 3. To add the 3, what? Plus the 5 minus the 2. But then if I have 7 and I want to take away the 3, what do I do? Minus the 5 plus the 2. Oh, no, you're fine. You're fine. So the next one, so then, I mean, that's what it would be. And then if you're looking for the bundle, I do have a bundle of the whole thing. I tried, so first grade, if you're looking for first grade, oh, sorry, let me continue on my thought. After learning how to make a 5, then you go into understanding how to make a 10, right? Making a 10 means what? Carrying and borrowing. That's what you're doing. You're carrying and you're borrowing. So you're using the next number over. So we add the 10 to carry over, or we subtract the 10 to borrow. So the first thing we do is we understand how to add the 10. And that's the concept. After you add the 10, right? And again, it's the same thing. If I have, we have to understand how to make a 10. We want to plus the 7 minus, plus the 10 minus the 3. So if I have 14 on the abacus, 14 on the abacus, 14 on the abacus, I want to add 7. To add the 7, I plus the 10 minus the 3. And then my final answer is 21. How do these work? They're breaking my brain. Oh, hold on, Gucci. So after you show them how to add the 10, then you do the minus the 10. And it's the same thing. Because you know how to add it, you will know how to subtract. And it works exactly the same. If I have 21 on the abacus, I need to take away the 10 plus the 3, right? If I want to add the 7. And I go through, and there's like activities for every one of them. And after you finish the lesson, then there are activities like color by number. There's a maze. There's a secret code. More color by number, and more mazes. Secret code. Oh, and I put in word problems. Yeah. And then if you're ever curious, I do have the answers in the back. There are answers in the back of like what I was thinking that was going to be expected. Yeah. So all my books have answers in the back except for the preschool one. I didn't think I needed it. So Gucci, are you still around? Oh yeah, not a problem. Not a problem. And then after that, but see the thing is I'm sorry, one more thing. The thing is if the children are a little bit older, then what I would do is instead of starting them off in the preschool book, then I would start them off with either the mazes of a 2-digit maze or the 3-digit maze, depending on how old they are. So this is where we practice what tens and the ones are, or we practice the hundreds and the thousands and the ones. So you look at the abacus and you need to tell me what the numbers are. And then you find the path. That's what the maze is. And then there's the reverse maze where I give you the number and you have to color it in. Yeah. So then the 3-digit is exactly the same except with 3 digits. So this would be for older kids, maybe second grade, right? They're doing 3 digits. And again, they need to understand how to read the abacus. And after they learn how to read the abacus, then they go into adding and subtracting. Okay, so Gucci, for coming over. Thank you so much for your patience. So what we're going to do is we're going to read the abacus. We're going to read 1, 2, 3, 4. That's what every column, every bead that touches the reckoning bar is counted. So this is counted. 1, 2, 3, 4. If I do this, then the top bead is a value of 5. This is counted. These are not counted because they're not touching the reckoning bar. So this is 5. Then we have 6. 5 plus 1 is 6. 7. 5 plus 2 is 7. 3. 1, 2, 3 plus 5 is 8. And then 4. 1, 2, 3, 4 plus 5 is 9. Thank you for the follow, Gucci. Does that make sense? So what we're doing is we're learning how to read the abacus. And then you might be wondering, well, why am I over here? I'm over here because there's a label. And this label tells me this is the ones place. Because I have the ones, then it'd be my tens, the hundreds, the thousands, and the 10,000s. That's it. Thank you, Jeremiah, for checking in. Thank you, Bots, for the rose. Thank you, Chaotic, for checking in. Hello, Chaotic. Hello, hello. How's it going? It seems to be quiet today. It seems to be very quiet today. All right. What are we doing? Hey, Ghosty. I do. I didn't think you were coming. Yeah, I was lifing. I was doing some grocery shopping and I'm like, oh my God, I gotta go back on live. So yeah, I am here. So the place values are ones, then fives, depending on what's connected to the bar. Exactly. So this is ones, 1, 2, 3, 4. This is ones, and then this is the 5. So if I was to count, I can use money. So I can do money. If I did 1, that's 1, 2, 2, 3, 3, 4, 4, and then 5. Notice I have to take away that, and that's 5. That's what 5 is. And then 6, 6, 7, 7, 8, 8, and then 9. That's 9. And then, what are we doing? 10. 10 is a 1. 1 and a 0. Yep. But they all have to be touching this reckoning bar. This is what tracks everything. If this is 10, this is 100. This is 1,000. This is 10,000. Does that make sense, Gucci? And then if we did it, like if we did the 5, it'd be 55,555.55. How hard is it to do division? It's not that hard. It's not that hard. You just need to know how to read the abacus, and then you just need to know some process. We could do some division. We could do some multiplication. Oh, excuse me. I just got tired. Okay. It's almost midnight. All right. How are we doing? No. Thank you everybody for joining. For those of you who are joining, please keep your mind open for something different.
Now, open your mind to me, please. Open your mind.
Okay. Well, before we get into multiplication, I think the first thing we need to do is understand how to add. So on the abacus, what you're going to notice is there's the beads, and the beads there's a ridge, there's an edge. So you're going to use the edge of the beads just to move the, and then you want to do it with intention. So we're do 1, 2, 3, 4. Don't flick. So if I have this, you don't want to flick, because if you flick, your answer is going to get wrong.
And flick. Oh, you flicked too hard, damn it!
So don't flick. And then what we're going to do is we're going to understand that if I have 2 plus 5, it's equal to 7. If I have plus the 2 goes to the horizontal bar, take away the 2 is away from the horizontal bar. Notice that when you add is the same thing as subtracting, just the opposite motion, right? So what we're looking at is minus the 3. All you got to do is take it away from the horizontal bar. You add the 2, add the 1, add the 2, you take away 2. Add the 2, take away the 2. Add the 5, take away the 5. Notice that the reckoning bar is what counts it, and if you need to add, you know how to subtract. It's not another strategy. So when we're looking, we have 5. This is 50. This is 500. This is 5,000. This is 50,000. 50, 0, 0, 0, 0.00. That's what that means. So the first thing we're going to do is understand how to add a 5. We're going to utilize the concept of 5. The reason why is because we're teaching this in school, but you need to, this is one of those critical concepts that you need to understand. 4 plus 1 is equal to 5. When are we going to use that? We're going to use it when we go to 4 plus 4. And again, we're not going to memorize our doubles. What we're going to do is we're going to understand how to use the 4. Using the 4 is the second number. The second number is going to dictate whether or not we use a formula. So I have 4 on the abacus, right? That's the 4. This is the 4. But then I don't have enough beads, and I don't want to do this because that means that would be 44. We're not looking at the tens. We got to put the 4 in the ones place. Because we have to put another 4 here, I can give you my nickel, but that's too much. I could take away the 1. And so my final answer is 8. 5, 6, 7, 8. I could do it again on the abacus. Add the 5, take away the 1, and my final answer is 8. 5, 6, 7, 8. And we could do it again with the 3. So the 3 on the abacus, like that, 3 on the abacus. And what are we doing? Well, we need to add the 4. To add the 4, we don't have enough. I have to give him this nickel, but this nickel is too much. So what do? We have to subtract, right? We have to take away the 1. What we're doing is we are subtracting for an addition problem.
If you're going hard enough left, you'll find yourself turning right.
Oh, right. That makes perfect sense. Turn right to go left.
For those of you that are trying to understand, it's kind of backwards, but it's really not. Because what we're doing is we're balancing the equation. We're utilizing the 4 in a different way. We know that 4 will be plus the 5 at 5 minus 1. You take a 5 and you take away the 1 from here. So we could do it again with the 2. So here's the 2. And I want to add the 4. To add the 4 is too much. Why? Why is it too much? Because if I add the 5, adding the 4 is too much. I have to take away the 1. So my final answer is 6. 5, 6. I add the 5, take away the 1, and my final answer is 6. How are we doing? I don't know who else is here. Hello, everybody. Hello. Thank you for joining. Thank you for joining.
This is the way.
This is the way. This is the way.
Kiro, thank you. Does that make sense? I'm so happy that made sense to you. It's been very quiet, so I don't know who's here. Kind of get it. Okay, good. Okay, good. I mean, we could do it again. Why? Because the concept, it's the concept. We want to go left to go right, right? We want to go left to go right. We want to add, we want to subtract to add. And why? Because the concept is 3 plus 2 is equal to 5. If I utilize this 5, I need to balance the equation. So when we go through this, let's do 3 plus 3. 3 on the abacus, 1, 2, 3. Oh, you know what? Let's do the packages. Maybe the packages will help. I have 3 on the abacus. I have 3 over here. Guess what? I want to add another 3, but I have no more room. I do have this package, but this package is worth of 5. 1, 2, 3, 4, 5. But guess what? I only need 3, but I don't want to break this package. Because I don't want to break this package, what I do is I want to take it from here. 1, 2. Right? So this 2 would be this 2. I'm just taking it away from here because it's easy to take away. So then I'm left with 6. 5, 6. So I could do it again with the 4, right? If I have 4 on my abacus, I'm sorry, I can add the 5, take away the 3. So take away the 2, sorry. So then I can do it again with the 4. I have 4 on the abacus. I have my package. My package is worth 5. 1, 2, 3, 4, 5. I'm only going to use 3 of the cubes, but I have to take away these 2. Because I have to take away these 2, I can't break this apart. So I need to take it away from here. 1, 2. And so I put it together. My final answer is 7. What grade? This is the fun grade. No, usually abacus is introduced probably around first grade, second grade. But I'm planning to try to introduce abacus to the higher grades, probably as high as fourth grade. Probably as high as 4th or 5th grade. That's pretty cool. Oh, thank you, Asbury. That's good. Yeah, I believe that, learning, visually seeing your numbers will help tremendous. It will help tremendous. So for those of you that are interested, I don't know what I've done. I'm sorry. For those of you that are interested, I do sell the abacus available. It is available in my TikTok shop. For those of you that are interested in more books, I do have it in my TikTok shop, or it's over here. My name is Lynette. I've never seen it, and I'm in 8th grade when school starts. Oh, that's okay. I had kids that came in my live, and when they start seeing it, like they're understanding it. So we can actually go into. Can you repeat? Oh no, thank you, Kai. We'll do a review. Let's do a review. I've noticed today that I've been doing math like this for years. Oh yeah, chaotic. That's really cool. Oh yeah. So Asbury, just so you know, I mean, I've had kids that come into my lives, and they start to see how to use the abacus, and it's been very beneficial for them. So for those of you that are coming in, thank you for joining. Thank you for joining. My name is Lynette. Math, then you should subtract the price. We should have 1. So when you notice, Asbury, we have 1. 1 is touching this reckoning bar. 2, 1, 2 is touching the reckoning bar. So this is 2. We have 3 and then 4. After 4, we have 5. The 5 will always be the top bead no matter what. 5 is always the top bead. And then we have 6, and then we have 7. 5, 6, 7. And then 8, 5, 6, 7, 8, and then 9. Make sense? Good. So after 9, we have 10. That's what 10 looks like. 10, if we look, do you remember your place values? You should remember your place values, right? Your place values, why is it like this? Because there's a label. See that label? That's my dot. That label tells me it's the ones place. So we have our ones, tens, hundreds, thousands, 10,000s. 1, 10, 100, 100, 1,000, 10,000. Yeah. Thank you, Asbury, for joining. Yeah, makes sense? Cool, right? Yeah, great, Kai. Yeah, okay, so we're going to continue on. So when you're looking, see, I'm happy that you're open to something different, even though you're in 8th grade. Because why? It's just different. And what we're doing is we're just doing very simple math. But the thing is what we're understanding is the concept. Don't memorize 3 plus 3. This is cool. I finally understand. I feel like I'm secret language. Or you're learning magic. It's all new to me. Thank you, Asbury. It is new, but see, you're willing to learn it. You're willing to learn it, which is really cool. It's really cool if you can learn it. I know some kids that actually learned it and they were able to excel in their math. But what we're doing, all of this is doing though, is only showing you how to read the numbers and then how to add and subtract. We can do multiplication and division on the abacus as well. Wait till you start showing the others. I seriously tell others how. Yeah, that's funny. That's funny. Oh my God. So 3 plus 3 would be blue on top. Yes, yes, but Kai, when we do 3 plus 3, we got to see it. 1, 2, 3. We want to add the 3, but we can't do it. Do you see that? We can't do it. We can't add the 3. So I'm going to give you, there's 3. 1, 2, 3. 1, 2, 3. I can't add the 3, but guess what? I have to use this package. This package is of 5. 1, 2, 3, 4, 5. Inside here, I can use a 3. This is the 3 I want to use. I want to use this 3. But I have to remove these 2 columns, these 2 cubes. Because I have to remove it, it's too difficult. But I can take it away from here. 1, 2. So I'm going to take it away. I could do that. Take it away. Right? I add my package, take it away. So that means that when I put it together, now I have 6. Oh, it's been around before Christ. It's been around for a very long time. Does that make sense? So I have this package, but it's too much. So I could do it again with the 4. 4 plus 3, right? 4, 1, 2, 3, 4. 1, 2, 3, 4. Plus 3. Again, I have my package. I have my package. I'm going to add my package. This is my package. 1, 2, 3, 4, 5. That's my package. But I'm only going to use the 3 here. Because I'm only going to use the 3, I need to take away this 2. Because I have to take away the 2, I can't do it from here because it's all glued, right? It's all stuck together. So I have to take it away from here. 1, 2, take it away. So I take it away from here. So my final answer is 7. We are doing this book right now. Excuse me. That is cool. Thank you, Kai. This is fun. Oh, good. Oh, good. We can start looking at some stuff. Asbury, you okay? Have you ever thought about making an app? Yes, I've tried to make an app, but I haven't. I've been trying to do it through AI, and it doesn't tell you. It doesn't show the abacus very well. So I think I'd have to modify it to only do questions. I wonder how now if my grandma taught this, because my grandma was a math teacher. I'm not sure if your grandma knows abacus. Abacus is very specific. Do it. I downloaded, but I prefer one from you. Okay. Yeah, I was thinking about having like all my questions in it. Yeah. That's what I'm thinking about doing. I just haven't just because I've been working on workbooks. I just published my 14th workbook and I got to continue on because I got to do the 2 steps. Once I get the 2-step, then it'll be no, because after the 2-step I have to do multiplication, and then after multiplication I have to do division. I think after I finish my curriculum, then I'll have time to do the app. Okay, I understand it. Okay, yeah, I understand it. Okay, good. Okay, good. You know what? Let's do this. Let's do something a little different. This is the maze. This maze is available. If you're interested, it is available in my TikTok shop. You guys have to let me know what number this is. So if I have this number, if I have this number, what number do you think that is? So I have my abacus, and it looks like it's 3 digits, right? So it's hundreds, tens, and ones. What number do you think that is? 711. Thank you. It's me. Yes, it is. Absolutely right. So then that's what 711 is. So then our next number is, what number do you think this is? I would have to ask my dad though to get it. Oh, what? You have an abacus? 2, 7, 7, 2, 6. Well done. Well done, Cow. You have an abacus, Asbury? That's really interesting. I wonder what kind of abacus you have. So we have 726. There we go. 726. And then we have our next number. What number do you think that is? No, to buy one. Oh, I see. To buy one. Yeah, you could buy one. There, you could buy this one. You're in 8th grade. You know what? I would suggest do this one. This is a 13 column one. The reason why I'd suggest to do this one is because then it will grow with you to do multiplication and division, and you don't walk around with this, because I think if you were to bring this, I think people would make fun of you because it looks very much like a toy, and if you want to be serious about it, maybe you take this one instead, which is a 13 column abacus. You know what I mean? Because I don't know how your classmates are in school. They might make fun of you. My boys, they brought the abacus to school, but theirs was a brown one. So it looks a little bit more serious. Why is there 2 dots? Ooh, that's a good question. 3. The reason why is because it groups. Just how we have groupings in our numbers. So we have our grouping and our number. Remember when we do numbers, we do 1 million, there's a comma, 0, 0, 0, comma, 0, 0, 0. So when I look, I do 1, 0, 0, 0. See how there's a thousands? And then 0, 0, 1. This is 1. I should do 1 here. That's why. That's why there's the dots. The dots. Oh, thank you, Chaotic. I'm going to go to bed. Oh, have a good night, Chaotic. Thank you so much for joining. So much for joining. Decimal points, yeah. Anything after the ones is a decimal point. So here's my ones. Then this would be my tenths, hundreds, and then thousands. Yeah. So the reason why the dots is to put the commas. So I know that this is 1,000. I know this is million. And then because this is million, I know this one is trillion. Thank you, Adore, for the rose. Asbury, does that make sense? Cow, does that make sense? Are we all right? Ah! Thank you for the follow, Adore. So does that make sense on how the abacus is? So because Asbury is in 8th grade or going to 8th, I would recommend the brown one, just because it looks a little bit more serious. But for the younger kids, probably about 6, I think 6 would probably be still with this one. I mean, I know adults, they can use any of them because it doesn't matter, right? It doesn't matter. They can use this one or they can use that one. And they just stay at home. But I think because if you're going to school, you might want to, I don't know if you're going to use it at school. I don't know if you can use it at school. You would have to be careful to show it to your teacher, because I'm not sure if they would welcome an abacus in school. Just so you know. Sometimes the abacus is for special ed. They might label you. Or they might think that you're gifted. Oh yeah, no problem, Asbury. So, oh yeah. So we're back to here. We have this number. Oh, this is easy. What number do we think that is? Yeah. Yeah, there's 2 extremes, and I'm trying to teach the ordinary people. There's those that are very special ed, and there's those that are, enrichment. 8. No, Asbury. Because if you look, we have 5, 6, 7. That's 7. 8 looks like this. 5 plus 3 is 8. 7. Thank you. Yes. Thank you, Joanne. 11. 11 looks like this. That's what 11 looks like. Yeah. 6, 7 looks like that. That's what 6, 7 looks like. 5, 6, 5, 6, 7. 67. So we have all the top bead is a value of 5, and then bottom bead's a value of 1. Oh, my bad. I mistyped again. So when we're looking, we have 5, 6, 5, 6, 7. There we go. So then we have 7, and then this is my next number. What number do you think that is? We have hundreds, no, tens, and then ones. Excuse me. 4, 2, 4, 7, 2. Well done, everybody. Well done. Yes, it is 472. 472 takes me to here. What number? Yay! Yay, Kiro. Yay. We have our hundreds, tens, and ones. Thank you, Asbury. Yes. 6, 2, 8. Well done. Well done, Kiro. Yep. Awesome. And then we have this. So we have hundreds, tens, and ones. So what is this specifically? Really, it's just a way to visualize numbers. That's all it is. Yes, thank you, user 293. 4, 6, 8. 1, 2, 3, 4, 5, 6, 5, 6, 7, 8. Well done. Well done. So then it takes me over here. And what number do we think this is? We have our hundreds, hundreds, tens, and ones. Thank you for the follow. How are we doing? 35, almost. It's 305. Don't forget the 0 is a placeholder. You're right. Thank you, Joanne. Almost, Asbury. So this one we have the 5, right? 300 would look like this. 305 looks like that. Ah, you were right. You were right. Yep. I'm happy that everybody's getting it. Yeah. I mean, it just takes time to understand what we're reading, right? Because it's unfamiliar. And it's easy, right? Simple to use, easy to understand. So we have our hundreds, we have our tens, and we have our ones. Excuse me. Yeah. Let's go. Let's go.
Oh, I love it. Great stuff.
Yes, thank you, Asbury. Yes. Yes, Kiro. Thank you, Joanne. Yes. It is 366. Thank you, everybody, for keeping your mind open.
Now, open your mind to me, please. Open your mind.
Thank you. Thank you, Kiro. Yes. 5, 8, 5, 6, 7, 8, and then 9. 5, 6, 7, 8, 9. Thank you. Thank you. Thank you. And then takes us to this. And then we are over here. Oh, we're not doing this one. We're doing this one. We're doing this one. That one. That's what we're doing. And it comes with an abacus. There's a little bundle that comes with an abacus. Yes. Hey, LMGS. I wish I could turn off other people's comments. I'm having trouble seeing something like how it carries all the way down. Okay, Ace is 8. Let's do that. Yes, 278. 278. And then 278, and then our final answer is here. We have our tens, hundreds, tens, and our ones. Excuse me. Thank you. LMGS 8, 6, 9. 8, 5, 6, 7, 8, 5, 6, 5, 6, 7, 8, 9. Well done. Well done. Okay. Here we go. Here we go. So the question is 9,999. On the abacus, I will show you. I will show you on the abacus because it's easy. Thank you for the question, Aces. Just so for everybody to understand, what we're going to do is we're going to understand the formula. One of the formulas is how to make a 9, how to make a 10. That's one of the things. Can you zoom out? Yep. So what we're going to do is we're going to do 9 plus 1 is equal to 10. 9 plus 1 is equal to 10. That's something that we're going to have to know. Why? Because what we want to do is we want to add the 1. Now when we look, 9999 plus 1. We know what this looks like in mainstream math, but what does it look like on the abacus? When we're looking, we need to know that when we want to add the 1, this is the 1. When we want to add this 1, we have to plus the 10 minus the 9. That's the formula. That's the formula that we need to know. Plus the 1 is equal to minus the 9 plus the 10, right? Aces, you still here? There we go. So when we're doing this, we want to make sure we minus the 9 plus the 10. So we have 9999. We are going to add the 1 here. That's what we're going to do. What did we do? We need to minus the 9 plus the 10. Minus the 9 plus the 10. 1, 0. 1, 0. Can't do it. Can't add the 1. So guess what? Minus the 9 plus the 10. 1, 0. 1, 0. Can't do it. Guess what? Do it again. Minus the 9 plus the 10. Can't do it. 1, 0. 1, 0. Do it again. Minus the 9 plus the 10. There you go. And now you're done. So we have 10,000, 000. Did that make sense? Yeah. It's like in programming, it's like a loop. You got to keep doing it until you can't do it anymore. You got to do it until it succeeds. You got to keep doing it until it succeeds. So it's like a little loop. You got to keep doing it until it succeeds. Yeah. Thank you. Thank you. Thank you, Pearl. But it is a little bit, it's a little bit advanced right now because it's intermediate, because you need to know the formula in order to understand how to do this. Because we see that there's not enough here, we know that we're going to minus the 9. So this is a formula. The formula comes from the addition sentence. The addition sentence, which is a fact family, the fact family is 1 plus 9 is equal to 10. So when the blue touches to start again, it's a 0. When the blue touches, this is 5. It doesn't start to 0. If it is removed, that is 0. Is that the question, Kiro? I'm not sure. So this is all 0, right? And if I want to count, it would be 1. 1, 2, 3, 4. But see, the thing was, the question was 9999. I want to add 1 here, but I don't have enough. So I need to use the formula. The formula is minus the 9 plus the 10. That's why. Yeah. What grade? This is the fun grade. I don't know. What grade? This one would probably be, I don't know, second grade? Maybe third grade? I get it. Okay, good. I think second grade. This would be a second grade question because it just matters on how many digits it is, right? I don't know. So that's the thing. Like there's a whole thing. Kuro, just so you know, I'm in ninth. Oh yeah, this is just adding and subtracting, multiplying and dividing. That's all we're doing. The abacus only does adding, subtracting, multiplication, and division. So let's do this one, right? So this one is adding of the 5. Adding of the 5 is easy. So if I have 9, and then add the 5. To add the 5 is what? Plus the 10 minus the 5. Plus the 10, take away the 5. That's all I'm doing. So my final answer is 14. You can do it again. I picked 9 because I wanted to see how 1 makes its way down. Yeah, and it's interesting because you could do the same thing with the subtraction too. Right? And then we could do it again with the 7. We have 7 on the abacus. There's 7. And then we want to add the 5. To add the 5, I want to plus the 10, take away the 5. So again, adding and taking away the 5 is something that you need to know. That's like one of those formulas. The formula is this, right? The formula is this. Could you do multiplication example? Yeah, we could do it. Yeah, we could do it. Multiplication's easy now because I've got questions. All right, so let's do some multiplication. Just so you know, we do distributive property and the abacus. I don't know where I went. I went this way. Okay, I got it. All right. I used ChatGPT to give me 10 problems through the break. Oh, good. Yeah, good luck. You can't ask Chat to give you an explanation because it won't tell you how to do it. You have to come to class. All right. So the first thing we're going to do is we're going to understand how to utilize distributive property. Kiro, this is going to be easy. You know your multiplication table, right? I might pick this up for my second grader. Oh, that'd be cool. I would for the second grader, I would start with either the 2-digit or the 3-digit maze. Did that make sense? Cool robot. I don't know if you were here for that. Cool robot dinosaur with a gun. This is good for summer lessons. It is good for summer. That's very positive. That's very positive. Okay, good. Okay, cool. Let me know if you want to see any of the books. Or how the books are made out. I can show you the books. Okay, so the first thing we need to do is understand we're going to have a discussion with our question. Why? Because we know, what do we know? We're critically thinking that our answer is going to be somewhere in the hundreds. How did I get that? 1, 2, 3. 1, 2, 3. We know that how do I know? Because I'm adding the digits together. I know it's going to be 100 somewhere, right? So when we do it, we're going to distribute a property means 8 times 4. That's all I'm doing. 8 times 4 is what we're doing, not 8 times 40. We don't need to do that. 8 times 4 is what? What is 8 times 4? Excuse me. What is 8 times 4? 32. Thank you, Pearl. 32. Add the 3. 1, 2, 3. Add the 2. 1, 2. Notice it says 320, but I did 32. The difference is the abacus keeps track of my numbers. The abacus tracks my numbers. I don't need to worry about place value. My next question would be 8 times 8. Is Thank you, LMGS. Thank you, Asbury. So what is 8 times 8? Thank you. 64. Add the 6. 5, 6. Add the 4. So what is my final answer? What's my answer? Can you read it? 3, 8, 4. Exactly. That's it. That's how you do multiplication on the abacus. 3, 8, 4. No, Asbury. Not 9. 9 looks like that. Thank you, Kira. Was that easy? Oh. I did it wrong. I didn't do it wrong. Yeah, it's easy. It's easy. We do distributive property. Sorta, but I get it. Yeah, right? It's easy. Where do I start? Here's my question. Where do I start? You let me know. I start in what column do I start in? If you could wake up tomorrow, 306? No. I'm not asking for the answer. I'm asking for where do I start on the abacus? I start 3. 1, 2, 3. Ones, tens, hundred. I start at the hundreds. Yes, thank you, Kira. I start at the hundreds. Yes, thank you, LM. Yes. So now what do? I do 6 times 5. 6 times 5 is? What is 6 times 5? Not 39, 36. Sorry, 30. You're right, 30. 1, 2, 3. 1, 2, 3. 3, 0. Don't forget there's a 0 here. This 0 is your place value. Thank you. So 0, 3. And then what do? 6 times 1. 6 times 1 is equal to 6. 6 is a single digit. So what we need to do is we need to make a 0, 6, like a two digit. We got to make this 2 digits. So it goes 0, and that pushes it over to 6. So I add my 6. So yes, Julia, you're right. 306 is the answer. $306 is the answer. Well done. Well done. I've seen a YouTube on 17 columns. They use the left in the middle of the answer. Yeah, I've seen that too. You could. But I don't, because I won't know where my place value is. Like, how do you know where the 0 is? You know what I mean? Like, if you put the answer, does the answer is the middle the ones place? That's what I wonder. Okay, what's next? We're going to go hundreds again. 1, 2, 3. 2 times 8. 2 times 8 is, see how easy Abacus makes it really easy. 16. Thank you, Pearl. 16. Add the 1, add the 6. 8 times 3 is what? Thank you, Kira. Yes. 24. Thank you, Pearl. 24. Add the 2, 1, 2. Add the 4. 1, 2, 3, 4. So what is my final answer? What's my final answer? Yes, thank you, Pearl. 184. 184. That's the answer. And then we go up to here. We have our next question. 1, 2, 3. So we do 8 times 7. 8 times 7 is equal to 56. Thank you. 56. Add the 5, add the 6. 7 times 5. 7 times 5 is 35. Yes, thank you. 30. 1, 2, 3, 5. There you go. So what is our final answer? 595. Well done. Well done. 595. And then it takes me to here. And that's it. So that's my maze. So that's how you do abacus. That's how you do multiplication on the abacus. That's it. There you go. 595. There's my maze. When we did it. Make sense, bro? Easy. All right. That was fun. Yeah. It's been good. I do have a bunch of mazes. Yeah, we started off with the 3 digits. I have a 4 digit and I have a 2 digit as well. For those of you who are interested, I do have books available in my TikTok shop or here. My name is Lynette and I've been... Can you multiply double digits more or no? Yeah, you can. Can you multiply double digits or more? Yeah, you can. It just gets complicated, that's all. We could do it, but then we didn't really do the formulas. You just need more columns, yeah. So here, like, I'll show you. So we have, I don't know, 56 times that by 73. We could do that. Well, I don't know how that would be, but again, distributive property means what? We take this one and then we take this one. So 7 times, it's 4. 1, 2, 3, 4. So we're over here in the thousands now. 7 times 5 is 35. Add the 3, add the 5. 7 times 6 is 42. Add the 4, add the 2. And then because we're done with that, you got to recount. 1, 2, 3. 1, 2, 3. So we know 5 times 3 is equal to 15. Add the 1, add the 5. Add the 1 plus the 10 minus the 9 plus the 5. 3 times 6 is equal to 18. Add the 1, add the 8. Whoops. So that's my final answer. Yeah, you just need more columns. Yep. Sorry I had to leave for a second. No worries. Yeah. Yeah, but see, the thing is you need to know, right? You need to know how to plus the 1 is equal to plus the minus the 9 plus the 10, right? You need to know your math facts before you go into bigger multiplication. What can't the abacus do? 4088. Yes. Thank you for sharing the live. Mexico again. Sorry. It cannot do like the higher maths, right? Like it can't do algebra, geometry, trigonometry, shapes. It doesn't do any of that. It only does adding, subtracting, multiplication, and division. Thank you for the share. Thank you for the follow, Big Chops. Yeah, it doesn't do calculus. It doesn't do trig. It doesn't do sine and cosine. It doesn't do any of that stuff. It only does basic arithmetic, basic math. Yeah. All right. What grade are we learning? I don't know. I think this is 4th grade. I think multiplication's 4th grade. It kind of blurs all over the place. Looks hard. It's not hard. It's the fun grade, right, Asbury? Yes, it's the fun grade. So let's do a review on how to count for big chops. 1, 2, 3, 4, and then 5. We have 6, 7, 8, 9, and then 10. After 10, we have 11, 12, 13, 14, 15, 16, 17, 18, 19, and then 20. That's a 2 and a 0. 2 and a 0. 19 looks like that. That's what 19 looks like. Thank you, Asbury. So when we have our place values, we have our ones, tens, hundreds, thousands, and 10,000s. And that's it. All right. I am going to head out. Thank you, everybody, for joining. Yeah, it would be a good summer thing. Thank you, Aces, for the gift. Of course. Yeah, it'd be good, it's just good to keep up with some thinking and stuff. Have a good sleep. Thank you. Yep, see ya. See ya later, Asbury. Thanks for teaching. Yeah, not a problem. I used to have... Have a good... Oh, yeah. Not a problem, Pearl. Thank you for the questions. Thank you guys for joining. Thank you guys for the questions and having a discussion and keeping it wholesome. Hey, thank you, 300. Welcome back. I didn't see you there. What's up? Thank you, LM. Yeah. I'll ask to get some. Oh, okay, cool. Yeah, it'd be good just to keep your brain active and until you start school again. But it'll be good. I think you'll be able to, Asbury, get through the whole curriculum within a couple of months. It's not that difficult. And it's so amazing. It's not difficult at all. But yeah. So, thank you again, everybody, for joining. Thank you so much for joining. I am going to head out. Hello, Lucifer. Thank you so much for following. Oh, I started again. Oh, yeah. My boys are starting August 12, I think. Yeah. Yeah, my boys are starting August 12. It starts early in Kansas. Oh, I'm in LA. I'm in Los Angeles. So I guess we all have the same timeline. Oh my goodness, you're up late. You should go to bed. Why are you up so late? Aren't you in East Coast now? Dude. You guys. Learning math in the middle of the night. That's crazy. Hello, Connor. You guys are learning math. You guys are learning math in the middle of the night. It's 2 a.m. and you're learning math. How crazy. That's pretty awesome. That's really awesome. Thank you so much for learning math in the middle of the morning. Early morning. You guys. That's dedication. You guys are dedicated to learning. I can't believe I'm dying. Yeah, right? I'm about to head out. Somewhat what? Somewhat. Oh, somewhat. Yeah. But you guys are learning math. It's pretty good. Middle of the morning. Or early morning. Yeah. All right. I am going to... Hopefully you guys will all have a good night. Hopefully you guys will... Dedicated. Oh, I see. Somewhat dedicated. No, you are. Because you're here. I don't know how long... How long have you been here? You've been here for longer than a minute. See? You've been here longer than a minute. You're pretty dedicated. There's not too many people that are dedicated to stay that long. Like 25? Yeah, it's 12:11. It is. I'm gonna head to bed. Thank you so much for the dolphin. Thank you so much for the dolphin. Thank you so much for the rose. Give or take. Don't sell yourself short. It's always about the things you say in your head. When do people stop learning math this way? thank you for the dolphin. I don't think they've ever learned math this way. That's what I'm trying to teach the average people. I'm teaching the matrix how to use the abacus.
Welcome to the real world.
Welcome. Yeah, I'm teaching the matrix how to use the abacus. I was homeschooled. I thought everyone did. No. No, not everybody did this. I should get some rest. Yeah, we should all do it. How do people use their hands to count, like the movements on the... Oh, because when you're moving it, add the 5 plus the 1. That's what they're doing, is that they know how to move the beads. Because they know how to move the beads, then they just do this. Yeah. Thank you, dumb. Pitch. Dumb pitch. Good night. Good night. Yeah, so if you're looking, it's just a bunch of this. But they do it in their heads. And it's muscle memory. Yeah. All right. Whew. That's cool. Thank you. Yeah. Yeah, it's really amazing when the kids do it. I don't push it. I just want you to be happy with math. I just wanted you to be comfortable with math. That's what I want you guys to be. You know what I mean? Like, don't be scared of math. And that's what I'm trying to do. I'm trying to teach the average person. I'm trying to teach the ordinary people, because it's on a spectrum. Those people that know abacus is either they're special ed or they gone into enrichment program. But I think what I want to do is I want to try to get to the average people. So I'm hoping that the matrix, I'm trying to teach the matrix how to learn abacus.
Welcome to the real world.
I want to learn how to actually be good at it. You know what? It's a lot about just practice. Thank you so much for the lightning bolt 300. Thank you so much. It's a lot about just practice. You just keep practicing it, and then you can do it. And then the numbers get a little bit longer and bigger. So if there'll be like bigger numbers, you just practice it. Let me see if I can find. Let's see. I guess I don't have it. Oh, here it is. Nope. No. So, I don't know. Sorry. What I'm saying is, it would be something like this. Like, you'd have to get more numbers. And the more numbers you get, then you can do it. But you just got to keep practicing. Practice, practice, practice. Can you show how to do multiplication? If I can. I can't do math. Whoa. Multiplication. So multiplication is this. So we'll do that. So the first thing we'll do on the abacus is we need to find our place value. 1, 2, 3, 1, 2, 3. And then we know distributive property. Because we're doing distributive property, we know we're going to go 8 times 4. 8 times 4 is 32. Add the 3, add the 2. And then we do 8 times 6 is 64. Add the 6, add the 4. So my final answer is 3, 8, 4. Yeah, you can, Asbury, you can. It's not an if, it's you can. You can. You can do the math. I believe everybody can do math. It just depends on how... It shouldn't have to be quick either. You know what I mean? So, Ryan. All right. Okay. Thank you guys, everybody. I'm gonna head out. I'm so tired. Thank you everybody for joining. Thank you everybody for joining. Have a good night. I will see you all in my next live. Please follow if you want to see me in my next live. All we do is talk about Abacus. That's all I talk about. Have a good night. Thank you. Oh yeah, you too. Thank you. Thank you for joining. Thank you for the questions. I appreciate it. But I can't believe you guys are still at 2 in the morning. Go to bed. All right. Thank you guys. Have a good night. I will see you all in my next live. Bye.